cooking. So, Unit 4 is all about, if I were to title Unit 4, I would call it this. The atom. Boom. This is what we are studying all of Unit 4. Highlight, 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 highlight. So that's why I would title the Unit 4, whatever. In Schoology, you'll see Unit 4 is atom, 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 atom. You're going to see it all over the place. Okay, so we got to talk about the subatomic particles. What makes an atom an atom? So sub means below. So like submarine is below the marine, the sea. Anyways, subatomic particles are the pieces of an atom. What's that? No, these are just regular notes that you're taking. So subatomic particles are all the pieces that make up an atom. So first off, we got protons. Those are positive. Some of you guys may have heard this before in like the 5th or 6th grade. I think you sometimes hit this kind of stuff. Protons are positive. They have a mass of 1. That's AMU. It stands for atomic mass units. I don't care if you know the AMU thing or not. That's not very important. And you will find them in the nucleus. Neutrons are neutral. They also have a mass of 1, and they are also found in the nucleus. So the only difference between a proton and a neutron is that a proton has a charge of +1. Electrons are negative. Their mass is quote-unquote 0. Okay, wait a second, Mr. P. I thought everything had mass. How's that possible? Picture this. All right, you got an elephant. It's sitting on a scale. It's got a mass of, I don't know how much, 100,000 kilograms? I have no clue what mass an elephant has. Let's just say it's 100,000 kilograms. I don't know. Let's say a little feather falls on top of that elephant's back. Like, oh, Mr. P, what's the mass of the elephant now? Be like, it's 1,000 kilograms. Or 100,000 kilograms. It's the same thing. Okay? So yes, the feather technically added mass, but do we really care? No, because it's so small compared to the rest of it. That's how electrons are. Technically, their mass is 0.000054 AMUs, but that's so much smaller than the other two, we just call it 0, because it's basically 0. Does that make sense? Okay? And electrons are found outside the nucleus. They're found outside the nucleus. Okay. Now, if I'm going to draw a little bit, okay, here's what a proton looks like. I draw a plus symbol, and I circle it. That's how I draw a proton. If I were to draw a neutron, I draw a 0 and circle it. That looks like a donut. Great. That's pretty good, right? There you go. Okay. Good talk. You guys like my art? Amazing. I was almost an art teacher. That's not true at all. I would never make it. All right. And here's how you draw an electron. Really creative stuff. The letter E with a negative symbol. Whoa! Yeah, amazing. Yeah, that's it.
Can we put a circle around it?
If you're feeling saucy, I guess you can put a circle around it. I don't. I just draw an E with a little negative symbol. That's it. They wanted it to look pretty different from a proton, so that's kind of the idea. That's kind of the idea. You will not see neutrons drawn very often. You won't see the donut, but you will see the protons and electrons drawn. It's including later in this lecture. All right. Okay. Woo! Exciting. Yeah, it's amazing. So fun. Love this class. All right. Now let's talk about what is on your periodic table. So this is the picture taken from the top left-hand corner of your periodic table. If you take a look at it, you see the little H up there. That's the same picture. All right. So the number at the top, that is the atomic number. We'll talk about what that means here shortly. The letter, or the two letters in the middle here, that is the symbol, or you can think of it as the abbreviation for the true name, which is right below it. So capital H, notice it's capital, that's actually important. Can't be a lowercase h. Capital H stands for hydrogen. You will see the capital H probably more often than you'll actually see the word hydrogen. So you need to know the symbol. That's important. And this number down here, that is the atomic mass. So the number with like a bunch of decimals on it. We'll talk more thoroughly about that as well. All right. So with that information, let's break down these different categories. Let's talk about the atomic number. Let's talk about the atomic number. Now, Colin, you might get a little confused since there's a couple things you missed, but we'll get you caught up if we need at the end, all right? The atomic number tells us the number of protons. And remember, protons have that positive charge. So some of you guys don't have to write the word positive after that, but just to kind of remind you, protons have a +1 charge. Okay? The symbol for atomic number is a capital Z. So at the end of this period, when we talk about the full atomic symbol, we'll be drawing a Z there. You'll see what I'm talking about later. The periodic table is arranged by increasing atomic number. So you'll notice the very first element has one proton. The second element has 2 protons. The third element has 3 protons. Like the order of the periodic table was determined by the atomic numbers of individual atoms. This is the most important piece of information about any atom, is its atomic number. Now this one, you better write down in big letters or put stars around it or highlight it, whatever. But this is very important. The atomic number can never change in an element. Ever. Ever, 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 ever. Okay? The atomic number is the definition of the atom. It is the atom's identity. Okay? Think of it this way. Let's say I took Colin here, I shaved his head and gave him a haircut like mine, gave him a buzz cut. Be like, okay, he's a Mr. P now. Be like, no, he's still a Colin. Still definitely a Colin. Okay? You can't change his identity. Like, he is Colin. You can't change that. Okay? Same with the number of protons. Like, whatever number of protons someone has, you can't change it. No matter what. You can maybe change some other things, but you can't change the identity of the element. Okay? So, for example, oxygen has how many protons? What's its atomic number? 8. It's on the far right-hand side. There are trillions times trillions of oxygen atoms in the universe. Like a number you can't wrap your mind around. And every single one of them has 8 protons exactly. No exceptions of any kind. If it doesn't have 8 protons, it is by definition not oxygen. Okay, I don't know what it is, but it's not oxygen. I can tell you that right now. Chlorine has how many protons?
17.
What if I was like, hey, Gozer, if this thing's got 3 protons, what does it have to be if it has 3 protons? Lithium, that's correct. What if it has 20 protons? It has to be calcium. And there's no exceptions to that rule. If it has 20 protons, I don't care what it has of anything else, it is calcium. End of story. No ifs, ands, or buts. All right. Now let's talk about the atomic mass number, though. It's a little different than the atomic number. So the atomic number was just the number of protons. The atomic mass number is when you add up all the protons and the neutrons for a single atom. So you take all the protons, add that number to all the neutrons, that's the mass. Which kind of makes sense, right? Because protons and neutrons have a mass of 1. So those are the 2 things that affect the mass of an atom. So you want to know its total mass. You're looking at protons and neutrons. The atomic number has the symbol Z. The atomic mass has the symbol A. You don't have to write this in parentheses, but this is another way of saying we're counting up all the stuff that's in the nucleus. Remember, protons and neutrons are in the nucleus, and that's it. So let's take a look at magnesium. Somebody find magnesium for me on the periodic table. Cece, you got it?
It's 12.
Okay. What's its symbol, first of all?
Mg.
Mg. Okay. What is its Z, its atomic number? 12. Love it. Okay. Now, what does this mass say? What does the mass say on your periodic table?
24.3050.
It says 24.3050. Okay. Now, one question remains is like, okay, well, what if I want to know the number of neutrons? Like, does that mean I have like 0.3050 neutrons somewhere? Like, how does that work? Here's what we're going to do. With atomic mass numbers, and I'll explain why this is in the next slide, we are just going to read these as the closest whole number. So the closest whole number to this would be, okay, so we're just going to call this a clean 24. We're going to call that a clean 24. And using that information, here's what we can do. So let's say I'm like, okay, that's great about the protons of magnesium, but what about the neutrons? Like, how many of those does that have? This particular magnesium. Like, okay, well, its atomic mass is 24, and that's protons and neutrons. Its atomic number, which is just the what again?
The number of protons.
Right? That is 12. So what can I do with those two numbers to find the number of neutrons? Yeah, if I find the difference between these two, so 24 minus 12, basically my protons will cancel out and I'll be left with just the neutrons. So A minus Z will tell you the neutrons, and in this particular case, there are 12. Final answer. So, Mr. Pilcher, are protons and neutrons always the same number? Absolutely not. This is a complete coincidence. Sometimes the protons and neutrons are the same number, but that it really is just luck of the draw. So don't get caught up with like, oh wait, the protons and neutrons are different numbers. Is that bad? They're like, nope, it just is. All right, you got two practice problems. Find the Z, the A, the number of protons, and the number of neutrons for Kr and K. Kr stands for krypton. K stands for potassium. They're both in the first 40 elements. So find the Z, the A, the protons, and the neutrons. Give me about 60 seconds, which might not be quite enough time for some folks, which is okay. I just want to make sure we get through all our practice today. Z, A, protons and neutrons. For krypton and potassium. K stands for potassium. Which that seems a little funky, but that will be explained to you later as well. Just not today. I'm going to bug on my virtual people for these, I think.
You want us to stop or not?
For
The
round. So that previous one, if it was 24.903050, you would call that 25. Does that make sense?
Yep.
Okay. Yeah, round. Good clarification. What's the Z for Kr? The atomic number.
36.
You got it. What is the mass according to this periodic table?
83.8.
Right. And what should you do with that? Closest whole number would be what?
Let's see, 84.
Love it. How many protons does this have?
Isn't that like altogether? Protons is 36, right?
Yep. The protons and the Z and the atomic number, those three things are all three different ways of saying the same thing. All the same thing. But then the neutrons, how many neutrons does this have to have?
That would be 84.
That's the mass of the whole thing. So 84 is how many protons and neutrons you have. If you have 36 protons, how many neutrons do you have? I hear him getting the calculator out. Let's do some math, baby.
48.
You got it, big dog. Awesome. Thank you, Mr. Williams. Okay. All right, not bad. Andrew, why don't you talk to me about K?
The Z is 19. A is 39.
Mm-hmm.
And then protons 19. And then 20.
You got it. Now, quick question. Don't write this next one down. I just got a quick question. I'll sit with you, Andrew. What if, so this typical potassium is about 39, according to the periodic table. What if this was not a typical one? What if this one's mass was 40 instead? What would that change?
The number of neutrons.
Why not the number of protons?
Because the atomic number stays the same.
Yeah, atomic number can never change. So if this was 40, that would force this to become 21. Does that make sense? Okay. So that brings us into our very next piece of information, and that is about isotopes. So an isotope is when you have the same element, but it has a different atomic mass. So you have two atoms of the same element, but they have a different atomic mass. As we just realized, the only way you can get a different atomic mass is not because the protons change, but it's because you have a different number of neutrons. That's the only way the mass can change, is if the number of neutrons changed. And now every atom, by the way, is considered an isotope. So let me see here. John, do you have any cousins?
Yes.
Name one of your cousins.
Jake.
Jake. All right, cool. So, let's say I go to John, his cousin's Jake over here. I'm like, hey, John, who's the cousin? He'd be like, Jake. I'm like, hey, what's up, cousin? He'd be like, oh, my cousin? No, that's John. I'm like, John, you just lied to me. You said that he was the cousin. I'm like, yeah, he is the cousin. I'm like, well, Jake, you said he was the cousin. I'm like, okay, Mr. P, like, he's my cousin, I'm his cousin. We're both cousins. Like, that's how this works. How do you not know this when you're 29 years old? Okay. That's how isotopes are. Every atom is an isotope of another atom. Okay, that's their relationship. So when two atoms are the same element, they have different masses, they're cousins or they're isotopes of one another. Does that make sense? Okay. Now the periodic table, this is the key idea, is the average mass. It's an average. So, take a look at chlorine. It's element number 17. Element number 17. So what does that mass say? Someone read that out to me.
35.4527.
35.4527. Okay. So this is the mass of the average mass of all the chlorines that we know. Okay. What this is saying is that chlorine is usually about 35, but sometimes you have chlorines with a mass higher than that. That's what that's kind of telling us. So a typical chlorine, okay, what will its mass be? A typical chlorine.
35.
Just 35, okay? So a typical chlorine has a mass of 35. Its atomic number at Z will always be 17. It is a chlorine after all. So that's never going to change. Its number of, let's switch back over here. Clark and Faith, make sure if I get in your way, just let me know. The number of protons will always be 17. But how many neutrons does a typical chlorine have? 18, okay. And that's a typical chlorine. But what if we have one of the heavier chlorines with a mass of 37? Let me see here. I'll go with you, Meg. What will the Z be? What would be the atomic number, the Z of the chlorine? Yep, still be 17. That can't change that. That's not possible. The mass would be 37 now. Okay, so I'm giving you that. How many protons would it have? Now, how many neutrons would it have? There you go. So that's what changes. So these two isotopes, they're the same in terms of protons, their atomic number, but their masses change because of the number of neutrons. That's what changes here. Okay? So these two are isotopes of one another. And you'll notice there is no chlorine atom, like there is no chlorine atom in existence that has a mass of 35.45. You're like, wait, but that's what the periodic table says. Like, remember, that's an average. So they're always going to have a mass of some whole number. So there's chlorines that have a mass of 35. There's chlorines that have a mass of 37. But there's no such thing as a chlorine with a mass of 35.45. It's kind of like when you're like 4.5 dentists out of 5 recommend Crest. Like, okay, where's the 0.5 dentist guy? Is that guy like all legs? Like, where's that guy? Like, no, that you don't understand. There's no half dentist somewhere. It's an average. Does that make sense? All right. Okay. Now, elements on the periodic table are called atoms. I use this word atoms specifically, okay? Because when I say the word atom, here's what I'm implying. Atoms are neutral or have zero charge. So if I say the word atom, you can rest assured that that thing I'm talking about has no charge. It's got a charge of 0. So here's what that means. When I say something has a charge of 0, that tells you for sure that the number of protons are always equal to the number of electrons. So if I'm like, hey, this atom has 50 protons, you know right away it has 50 electrons. Hey, this atom has 17 protons. Boom, well, it has 17 electrons too. Okay? If it's an atom, it's neutral, and therefore the protons, so again we got our little positive symbol, right? Protons is equal to our electrons. So just give you a little bit of a visual. If I'm talking about carbon, okay, it's got how many? Yes, yes? Question?
I have a question.
Yes. What's up?
So some of the elements on the periodic table, like they don't have decimals after them. So do the masses like those, are they always the same?
Are you talking about like the ones at the bottom, like element 104, 105, or that kind of thing?
Yeah.
Here's the reason for that, Lexi. Those elements last for like a fraction of a second. And so we have never been able to get the mass for sure. So like element 104, for example, we think its mass should be about 261, but we don't know that for sure because we've never been able to measure it. Does that make sense?
Yeah.
Yep, so that's why it's not an actual measurement, it's a guess, educated guess.
Okay, thank you.
Yep, good question. So carbon's got 6 protons, it's element number 6. So it'll have like 6 protons floating around. So if it's an atom of carbon, how many electrons does it have to have? 6. Okay. So this is a +6 charge here. Now it's a +5 because that cancels out. Now it's a +4, +3, +2, +1, and 0. Okay. So there should be an electron for every proton to cancel out that charge. Now that brings us to ions. So ions are a particle that's become charged now, so we can't call it an atom anymore because it must have gained or lost electrons. This is very important. It didn't gain or lose protons. That's not possible. You can't change the number of protons. That's impossible. But the number of electrons can change. I mean, think about it. Electrons are tiny. They're not in the center of the atom. They're a lot easier to add or remove. A negative ion, which just sounds a little backwards, but a negative ion has gained electrons. So like, wait, if it's negative, wouldn't it be losing? But remember, electrons are negative, so that would actually cause it to have a negative charge. So it's got more negative than positive. There's a special name for that. It's called an anion. So, if Muhammad is anti-bullying, that means he's negative bullying. He's like the opposite. He's against bullying. He doesn't approve. Okay? And anion means a negative ion. So that prefix "an" means like negative or opposite. On the other side of that, you got the positive ion. That's when you've lost electrons and you have more positive than negative. Guys ready for a couple sweet dad jokes? Coming in. You guys need them. These notes are rough. So I got some good dad jokes. A positive ion is called a cation. And here are 2 dumb ways to remember that. Are you ready? You guys excited? I know you are. Here's way number 1. So I'm writing out that word, cat ion. Wait a second. Do you guys see that? Is that a proton right in the middle of that? Reminding me that it's positive? You guys see that? Amazing. Or you can think to yourself, cats are so positive. Does cats have paws?
Is it too late to drop out of this class?
Is it too late to drop out of this class? Yes, you're trapped with my bad jokes for the rest of the year. Yes. Thank you, Mr. Williams. I don't sense any sarcasm in your voice whatsoever. I appreciate it. I know you guys who are watching the recording at this point can't see how hard everyone in class is laughing. I got a couple kids on the floor crying. This kid over here peed his pants a little bit. He's laughing so hard. We're having a good time. We're having a good time. True story. All right, anyways, let's compare a lithium neutral atom with a lithium with a +1. Let me see here. Who do I want to pick on? I'll go with that Colin. Boom, right there. He's like, dang it, me? Colin, this is a lithium. How many protons does it have to have if it's a lithium? Lithium, top left-hand corner. Yep, has to have 3. All lithiums, by definition, have to have 3. Oh, my infinite cloner's not working. Good memento. There you go. Nope. Right click. Infinite cloner. Here we go. So this lithium's got 3. What? Oh my, I'm just gonna do this. I'm gonna do this instead. Okay, so what about this lithium ion? How many protons does it have to have? Yep. So they both have to have 3 protons because there's no changing that. No matter what, if it's lithium, by definition, it's got 3. All right, now this one is neutral. So how many electrons does it have to have? If it has no charge at all and has 3 protons, how many electrons does it have to have? Yep. It has to have the same number of electrons. Okay? Now this one over here has got a charge of +1, so I know everyone's going to say it either has 2 electrons or 4 electrons. They're just not sure which one it is. Like, I know it changed by 1, but which one is it? If it's positive, does it have 2 electrons or 4 electrons? It's going to have 2, right? Because this electron will cancel out that charge. This electron will cancel out that charge, but then this charge is off on its own, and it's going to remain +1. Does that make sense? So it lost an electron, but the charge is now positive. Okay? That's kind of how that works. Now we're at our last slide today of notes. So let's talk about full atomic symbol. So this is an example. So in the middle you have the symbol. There is no element X, by the way. That's why I chose this letter. There is no element X. Don't go looking for it. It's not there. So in the middle you have the atomic symbol. So for hydrogen, that's a capital H. For lithium, that's a capital L, lowercase I, and so on and so forth. In the top left-hand corner, you have the atomic mass. In the bottom left-hand corner, you have the atomic number. In the top right-hand corner, you have the charge. So for example, if I was like, hey, give me the full atomic symbol for a hydrogen atom. Here's how you go about doing that. So you think to yourself, okay, well, he didn't tell me anything about the charge. He didn't tell me about any of the neutrons. So you are forced to assume it is a typical hydrogen with no charge. Okay? So a typical hydrogen with no charge, well, I look at the mass, 1.00794, so typical hydrogen is going to have a mass of 1. Its atomic number is still going to be 1 no matter what. That doesn't matter if it's typical or not. And the charge is just going to be 0. Because you said it's an atom, Mr. Pilcher, and all atoms have a charge of 0, so that's the best I can do. A fluorine -1 ion. Okay? So let's see here. Do neutrons affect the charge at all? Okay. All right, so the neutrons shouldn't have changed at all. So the mass of a typical fluorine is 18.99, so I'm going to go 19. Can the charge affect the number of protons in any way? No. All right, well, fluorine is atomic number 9, so that's 9. And then we just indicate, hey, this is a -1, because that's the charge that you gave me, Mr. P. So I'm going to write that. All right, then we got nitrogen. We're told this is the number 16 isotope. So if you look at nitrogen, it's element number 7. It's in the top row on the right-hand side. A typical nitrogen has a mass of 14. Usually has a mass of 14, but we're told, hey, this one's got a mass of 16. It's like, okay, I'll write that there in the top left-hand corner for my A. Its atomic number is still 7. Mr. Pilcher did not tell me there was a charge or indicate that in any way, so I assume it's 0. So let's put a 0. And that's how you do full atomic symbol. Now let's go ahead and take a look at our worksheet real quick. This top chart is just sort of beginning of your notes. This is just for notes for you. Let's talk about one of these problems. We're going to do SN. That's element number 50. It's tin together. So, in all of these rows, I've given you enough information somewhere in the row to answer the rest of the row. So we're told that this particular tin has 70 neutrons and 54 electrons. Not all tins have 70 neutrons and 54 electrons, but we're told this one does. Okay. So if it has 70 protons and 54 electrons, let's answer the rest of these. What is its atomic number? What is tin's atomic number? Has to be 50. All tins have an atomic number of 50. So that doesn't matter what these numbers are. You could fill it in at the very beginning without looking. This particular tin's mass must be what? Remember, mass is protons and neutrons. This particular tin's mass is it's 120. The 50 plus the 70. You'll notice on your periodic table, tin's mass is listed as 118.7. So normally it's about 119. But this particular one with an extra neutron is 120. Okay? How many protons does it have to have? 50, right? I mean, these two, the number of protons and the Z, that's the same thing. Those are always the same thing. They mean the same thing. All right. Now, let's do the full atomic symbol. So the atomic symbol is an SN. This particular one's mass is not 119, it's 120. Because we're told it has 70 neutrons. Its atomic number is still 50. That's true for all tins. And what is the charge of this tin? Cece?
-4.
Where'd you get that from?
Because it has 4 more electrons than it does protons.
Yep, absolutely. So this has to be a -4. Let me show you one last thing you can put in your notes that will probably help you. Or you can just write at the top of this worksheet. When you're dealing with charge, here's an equation that always works for charge no matter what. Charge will always equal your protons minus your electrons, no matter what. So if you have more protons than electrons, that will come out to be a positive number. If you have more electrons than protons, that will come out to be a negative number. Either way, you're correct. If you have the same number of both, it'll come out to be 0, so it's fine. So a lot of people like to write this one down, or they'll write that on their periodic table. You're allowed to use your periodic table on all quizzes this unit, except for one quiz, but I'll tell you when that is. But you can use your periodic table any other time you want on the quizzes, not tests. So you got a lecture quiz. Virtual folks, I recommend you do the lecture quiz right now. Live folks, you can try right now if you want. We only have 3 minutes of class left, but you can knock out the lecture quiz if you want. If not, work on this worksheet. The answer key to this worksheet is in the Monday folder, and you guys are free to go.